Today, we are going to learn how to explain the uses of shunt and multiplier. In electronic, a shunt is a device that creates a low resistance path for electric current to allow it to pass around another point in the circuit. The origin of the term is in the verb to shunt, mean to turn away or follow a different path. Shunt is a device which allows electric current to pass around another point in the circuit by creating a low resistance path.
And multiplier. Okay, let's look at this in page 115 from your reference book Oxford Fajar. A moving coil galvanometer has a low resistance and the maximum permissible current vary from few micro ampere to few milliampere. Large current will burn the coil. Okay, so what does the sentence means, class? Now we have a galvanometer, which is a moving coil galvanometer. This moving coil galvanometer, it has a very low resistance. Okay, so because it is a very low resistance, alright, so when a current pass through galvanometer, what will happen is this current will burn the coil of the galvanometer. That's why it says large current will burn the coil of the galvanometer. So what is the solution to this problem? The solution to this problem is, if we don't want our galvanometer coil to burn, we can fix a resistor which is parallel to the galvanometer. Why we do so is, we want to direct only small current into the galvanometer and direct the biggest current or bigger value of current through another or through this resistor. So this is called as shunt. This is called as what? Shunt. Shunt is actually a resistor. Shunt is actually a resistor. And its resistor, number one, the keyword here is a resistor. The second keyword is resistance is lower than that of the galvanometer. The second keyword is the resistance is what? Is lower than that of the galvanometer. Okay? Why? Because that means the resistor of the resistance of this shunt resistor, the resistance will be lower. Because this makes sense, class, because we know the formula V equals to IR. I is inversely proportional to R. So when R is greater, I is smaller, and when R is smaller, I is greater. So the resistance of the shunt should be lesser than the resistance of the galvanometer, so that large current can use another alternative way to flow rather than all go into galvanometer and burn the coil. Okay, keyword number 3, it is connected in parallel. Okay, connected in what? In parallel with the galvanometer. Hence the current in the shunt is greater than the current in the galvanometer. Okay, so that is true lah, because of the resistance difference, the current in the shunt is greater than the current in the galvanometer. Okay, so let's look at the next page. Let's look at figure 15.15, which I'm going to draw here. Now in figure 15.15, the mission is to find the value of R. Okay, so we have a galvanometer, alright, and then we have a shunt, okay, a resistor, which is fixed in parallel to the galvanometer. And what happened is large current flows, which is a 3 ampere. Okay, so if you read point number 4, the point number 4 says the galvanometer has a full scale deflection. Okay, so what does the sentence means, class? If you see point number 4, the galvanometer has a full scale deflection of 15 milliampere. Now what does this the sentence means? The sentence means that current that pass through galvanometer maximum can be only 15 milliampere. Okay, 15 what? 15 milliampere. So out of this, the larger current will flow through this resistor, which is a resistor R. So how much will flow in this process here? It will flow is 2.985 ampere. So larger current will follow another alternative way. Okay. So now when larger current follow here, it will go here, and then this one will flow this side, and it will go into it will join and go in this path. Okay. So now we want to find the value of R. Just another example of how to use some concepts here to solve the value of R. Now this is parallel. So if this is parallel, this voltage from this point to this point, this point to this point, the voltage is the same. Okay, the voltage is the same. So I'm going to write there VG equals to VR. So the voltage here to here, the potential difference from this point to this point is called VG. The potential difference from this point to this point is called VR. Okay, so what is VG, class? VG is of course I times R. I is 15 times 10 to the power of negative 3 ampere. Okay, and R is, do we know the R? The R is 10 ohm. Okay, it's given in the example, in the figure. Okay, and then VR is the potential difference from this point to this point. So we have 2.985 times with R. Okay, so if we calculate this, okay, I'm going to just calculate this. 15 10 to the power of negative 3 times with 10 divided by 2.985, I will get my answer is R is 0.05025 ohm. Okay, so this is the value of R. So this really makes sense, class, because the value of R is lesser than the value of R which is in galvanometer. So that makes sense that the current that flows in the galvanometer is lesser than the current that flows in the shunt. Okay, so from the relationship, V is inversely proportional to R. Okay, so this is shunt. Okay, another use of shunt is, okay, that actually we can convert by using a shunt. We can actually convert a galvanometer into an ammeter. So this whole thing can become an ammeter. So a shunt is connected across the galvanometer to convert it into an ammeter to measure large current. So this is one of the uses of shunt. Okay, now where did I get that? I got it from this point number 3. A shunt is connected across the galvanometer to convert it into an ammeter to measure large current. Alright, okay. Thank you, class.
Multiplier. A multiplier is a high resistant. It is usually used to convert a galvanometer to a wattmeter. It is usually connected in series with the galvanometer.
Next one, which is a multiplier. Okay, multiplier, point number 1, it is a resistor. Point number 2 is a high resistance. Point number 3 is in series, okay, with the galvanometer. And point number 4, the same galvanometer can also be converted into a wattmeter by connecting a multiplier in series with it. Okay, so now let's look at this. First thing we know, a multiplier, point number 1, it is a resistor. Okay, and then we also know multiplier is a resistor which has a resistance, a very high value, so high resistance. Okay, and then if you, how do you use a multiplier? You must connect it in series. Connect it in series with galvanometer. Okay, and if you connect it in series with a galvanometer, the galvanometer can be converted into a voltmeter. Can be converted into a voltmeter. Okay, now let's look at one example of a circuit, which is a figure 15.16. Now we have a galvanometer here, and then we have a multiplier. Okay, now the current that flows in the galvanometer is 0.015 ampere. The same current also flows in the multiplier, which is a resistor with a resistance R. Okay, so 0.015. The book says that the galvanometer resistance is 10 ohm, and the potential difference from this point to this point is 6 volt. Okay, is how much? Is 6 volt. Okay, they are connected in series. So this is point P, this is point Q. So VPQ is equals to VG plus VR. VPQ is 6. VG is what? I, which is 0.015 times with 10 plus with VR is I, same current, times with R. Okay, so 6 equals to, here will be what? I take out a 0.015 0.15 plus 0.015 times with R. So take this minus 6 minus 0.15 is 5.85 equals to 0.015 times with R. So therefore the value is 390. So R is 390 ohm. So if you can see here, if you can see the difference here, the resistance in the multiplier is 390 ohm, but the resistance of the galvanometer is 10 ohm. So it shows, it's truly true when it says it is high resistance. Okay, so it's truly true when they say the word is high resistance. So that is about multiplier class. So that is the reason why you see I've explained point number 10. Okay, so that is all about shunt and multiplier. Thank you, class.